So matrices are useful for a lot of things, and one of them is solving simultaneous equations in multiple variables. There are several methods that can be used for this process, including elimination, which you might remember from GCSE maths, as well as more advanced techniques, such as reduced row echelon form at university level. The matrix method is good because it's very formulaic, and you can easily extend it into solving linear simultaneous equations in 4 variables, 6 variables, 10 variables, and then you can solve it using computer programming. This idea also ties in neatly with some other matrix algebra, as well as some plane geometry, which I'll cover in a separate video. This video will just be on the process of solving 3 linear equations or obtaining them from wordy questions, as well as briefly why the method works. So I've got an example here where we have 3 equations straight away, and the first step I'm going to do is to rewrite them in the form of matrices. So what I mean by that is like this, with the different variables. So I'm copying the coefficients of x, y, and z into separate matrix. And if we then multiply that by the 3x1 matrix x, y, z, then we will get 1, 2, 0. Because if you multiply those 2 matrices together on the left-hand side, then you will get the initial set of equations. So then after that, what we can use is a bit of our knowledge on inverses of matrices in order to rearrange this and make the x, y, z component the subject. So what we can do is we can multiply both sides of this by the inverse of this matrix here, because of the property which, if we have a matrix A and we multiply it by its inverse, then you should know that that will give us the identity matrix I. And of course, it doesn't matter if you multiply them the other way around either. So in this case, for this set of equations, the inverse matrix of 2, 3, 1, 1, 2, 1, 3, 1, 1 is, and you can use the method to find an inverse of a 3 by 3 matrix, but in this case you could also just calculate it, and it gives you 1/3 times 1 minus 2, 1, 2 minus 1 minus 1, minus 5, 7, 1. That's the inverse of that matrix. So what we're going to do is multiply both sides of this equation here by this matrix, by the inverse matrix, in order to make x, y, z the subject. So that's going to give us x, y, z equals 1/3, and then the inverse matrix times 1, 2, 0. And then we can multiply those 2 matrices together to get our matrix x, y, z. And in this case we find x, y, z is in fact -1, 0, 3. So those are our values for x, y, and z. And we've solved that using matrices. So the other thing you have to know about with this is how to solve wordier simultaneous equations using matrices, where you need to form the equations yourselves before solving them. So I've got a past exam question here, and we'll read it through first. So it says a college offers only 3 courses: construction, design, and hospitality. So most likely here we can label our 3 variables C, D, and H. In 2019, there was a total of this number of students at the college, and there were 370 more students enrolled on construction than hospitality. And since we've got 3 variables, remember that from this information we want to form 3 separate equations. And then we're told in 2020, the number of students enrolled on each of these courses and then the percentage of how it's changed. So that will be useful for one equation. In 2020, the total number of students at the college increased by 0.27% to two significant figures. And the question asks us to define a variable for the number of students enrolled on that course in 2019 and to write down three equations to model the situation. So, initially we've been told that there were 1,110 students at the college. So our first equation is C plus D plus H equals 1,110. And technically we should also write down what they stand for. So C stands for construction and so on. And for our next equation, we will write down the scenario from 2020 using the percentage multipliers. So that tells us that we have 1.0125 C, and I'm using percentage multipliers, decimal multipliers given by these percentage changes. Add 1.025 D, add 0.98 H equals, and then we have 1110 times 1.0027 to two significant figures. And for our final equation, we were told that there were 370 more students enrolled on construction than hospitality. So that tells us that H plus 370 equals C. But we need to rewrite this in a form that's more similar to this one. So we will rearrange to make 370 the subject of one side. So we have minus C plus 0D plus H equals minus 370. And now that we have our three equations in C, D, and H, we can start using matrices to solve them. So I'll come down here to do this. So we have 1, 1, 1, 1, 1.0125, 1.025, and 0.98. And then we said that we had minus C, 0D plus H. So minus 1, 0, 1. We multiply that by our variables. And we know that that's going to give us, the total was 1110. The total of this was 1110 times 1.0027. And the total for this was minus 370. And then if we find the inverse of matrix A, then we can write out that A minus 1 times A times CDH is going to give us A minus 1 times our matrix over here. And this is approximately equal to 1113 minus 370. So we know that these two matrices here, these can be rewritten simply as I. So we have I lots of CDH equals the inverse matrix of A times this matrix here. And when we solve, that will give us CDH equals 720.05 39.896 and 350.05, which is approximately equal to 720, 40, and 350, which we know add up to our correct total of 1110, and therefore that's a good check to see if we've done this correctly. But that is the correct answer to this question.